Hi, everyone. My name is Farrukh Khan, and I am going to talk about HTCondor at Fermilab. I'm presenting on behalf of the Compute Science and Infrastructure Group, which is part of the Computational Science and AI Directorate at Fermi. So I know it's been sort of a long day. We have had so many nice talks, so much to absorb. So I'll try to keep it light and breezy, and let's get started. So first, an introduction of what Fermilab is. So Fermilab is, or Fermi National Accelerator Laboratory, is one of the leading centers of particle physics and accelerator research in the world. So we host a lot of cutting edge experiments at Fermi, and we have scientists that are working on problems in quantum science, particle physics, dark energy, dark matter. Other than our own research, Fermilab is also contributing to a lot of other research facilities in the world. So Stanford Underground Research Facility in South Dakota. We have LHC at CERN in Switzerland, and then the South Pole Telescope. Fermilab is managed by Fermi Research Alliance. It's of course funded by DOE, Office of Science. Fermi Research Alliance is a partnership of University of Chicago with URA, and URA itself is another alliance of many research universities. So in the spirit of keeping things light, I kind of want to share my first Condor week experience with you guys. So I first came across Condor when I was hired as the CMS Global Pool Operator, and this was back in 2014. So I did what anyone would do, right? You Google it, or as one of my friends likes to call it, you Bing it, or maybe DuckDuckGo it. So yeah, anyway, I Googled it. And I found Condor Week videos from 2008. They were hidden somewhere on the HTCondor website. Now it's much easier, of course, with the YouTube channel. But back then, yeah, I mean, those videos were like 6 years old. And I thought, okay, it's still a starting point. So I decided to give them a go. And of course, they were very, very helpful in getting me started with Condor. And just watching Condor Week, even if it was virtually, it was pretty exciting. One thing I do distinctly remember, and I'm not going to name any names, but there was this dapper fellow, he came to the stage behind the podium and talked about Condor and kept comparing himself to George Clooney. So that I distinctly remember from that Condor Week. No names, I'm not naming any names. So after, experiencing Condor Week, I started looking at the slide decks that CMS had about Condor training. And almost every slide deck that I opened started with a slide saying Condor is king. And I was like, yeah, this must have been written by one of the developers. These developers, they get attached to their projects like it's their baby. Took me a few months to sort of realize what that slide meant. And here I am 9 years from that point, and I'm starting with Condor is king. So at Fermilab, I think it wouldn't be wrong to say that Condor is the most important piece of our scientific computing infrastructure. Other than scheduling workflows, we have a whole ecosystem built around HTCondor. And since I wanted to sort of write a talk where I did the least amount of work, I'm going to do lots of callbacks and shout outs to people. So several tools like Gliding WMS, you're going to hear about it tomorrow from Bruno and Namrata. You have heard about it from Marco in the past. We have JobSub. Shreyas is going to talk about it tomorrow. Decision Engine has been discussed during Condor weeks as well. One of Fermilab's flagship projects, the HEP Cloud project, which allows us to tap into HPC and cloud resources, is heavily reliant on HTCondor, and that's a candidate for understatement of the year. Our monitoring, FIFEMON, which has been presented at Condor Week as well, relies heavily on it. We use the metrics coming from Condor. And as Kevin Retzky, the guy who manages FIFEMON, likes to say, the dashboard for that. So as you can see, we are heavily vested in Condor. We have lots of clusters, pools, facilities, whatever you like to call them, that utilize HTCondor. And yeah, like I said, I'll keep it short, I'll keep it simple, and I'll be doing lots of shout outs to people. CMS Global Pool, as we already heard from Marco Mascheroni just before us, it's essentially the one pool to rule them all. CMS run all of their production and analysis work through this pool. So just like the OS pool, it is a Glidant WMS pilot-based pool and utilizes HTCondor pretty heavily. We at Fermilab are part of the submission infrastructure team that operates this pool. So that means we do run half of the infrastructure over at Fermi. I'm talking about the central infrastructure, so central managers, CCBs, front ends, factory. We do also provide access points for CMS production team. So they can not only access the global pool resources, but they can also access the HEP Cloud resources through these access points. This is just, the last week's usage. Marco also showed a similar graph. So you can see holding steady at 400,000 CPU cores, like it's nothing. Next pool, Dune Global Pool. So we've seen how much success CMS has had, with their global pool. So we're now trying to sort of apply some of the lesson learns and, just in general, extend the same concept for Dune. So Dune, or Deep Underground Neutrino Experiment, is one of the flagship experiments at Fermilab. So we have recently commissioned a global pool for them as well. Again, it's a Glidant WMS pool, and the whole infrastructure is operated, central infrastructure is operated by CSI at Fermilab. The access points for the pool so far have been, at Fermi. We have one at Brookhaven. We have also got one at Rutherford National Lab, and we are looking to put one for CERN as well. I couldn't find a very nice plot to show for this because we are still, like I said, finding our feet with this pool. Hopefully next year we'll have a dedicated talk for it. Elastic analysis facility. So you see a lot of these popping up lately. So it's a facility for users. The project is being led by Bert, Maria, and Chris. So the idea is that this is a facility where users get to bring tools that they find helpful in their analysis. The idea is that the traditional facilities were built with production in mind. So this allows users to sort of do their own thing. This facility is entirely containerized. The HTCondor component to it is in the interactive notebook. So we have Condor adequately configured in these notebooks. So users, when they log onto these notebooks and do whatever analysis that they want to do, they are going to, they have the capability of breaking into our facilities by job submission as well. Again, shout out here, Maria tomorrow has a talk. She'll specifically talk about how users use Elastic Analysis Facility and Condor to run their DASK job on our facility. So do attend that talk. One of our goals is to sort of go the other way around as well. So users can come to the facility. We should be able to break into the OKD cluster as well on demand. And that's still on our wish list. We are not there yet. Fermi Grid Compute Facility. So this is one of our bigger facilities. It's meant for all the experiments that are at Fermi, and it's meant to provide a common interface with this job sub. And again, Shreyas is going to talk about it tomorrow. The facility is not just operated by us as in CSI, it's a collaboration among different teams in the directorate. We have 5 access points, 2 compute entry points, and around 500 execute points. I keep calling them execution points for some reason. Where jobs go to get executed. Anyway. So 35,000 cores. The pool has a Glidant WMS front end, which uses the OSG factories to get us pilots on the grid. And then, of course, it also has a decision engine, which is part of the HEP Cloud project. So we can tap into HPC sites and cloud instances. So this is just a plot of showing last week's usage. And apparently Nova got a huge chunk of it. So good for them. Next up, CMS Tier 1 and LHC Physics Center facility. So this is our largest facility by size. It's primarily reserved for CMS usage. Using the power of HTCondor, we have virtually divided this facility into 3 partitions. So one as the tier 1 for CMS global pool, one for the US CMS users, which are at Fermi. They're also called LPC users. LPC is LHC Physics Center. And then, of course, the third partition is for HPC and cloud resources, which CMS production uses. 6 compute entry points, 9 access points. We have around 500 execute points in this cluster as well, with around 40,000 cores powering it. The tier 1 facility at Fermi is second largest compute resource provider to CMS outside of CERN. And again, it has a decision engine component, so it can tap into the cloud or HPC if CMS needs it to. The green here, of course, is the CMS global pool accessing the resource. The blue you see is the user analysis, and then the spikes of orange is sort of breaking into HepCloud. So this was sort of like a bird's eye view of all of our facilities. So as you can imagine, if you use something this heavily, there are bound to be uses and abuses of that software. So at the risk of getting stoned by the developers, I decided to sort of do a list of things, and I'll let you be the judge of whether that's a use or an abuse. Unfortunately, I didn't have time to go over all of it. I'll try to touch them all, but one that I really wanted to focus on was how we use Docker in our facilities. So I'm going to do a lot of did you knows. Most of you probably already know this, but still, did you know that the Docker knob in HTCondor doesn't actually have to point to the Docker binary? And did you know Condor allows you to add as many knobs as you want to by yourself? I think I'm going to start socializing the term. There is an auxiliary knob for that at Fermi because of the custom knobs that we built into HTCondor, doing a lot of crazy things. So at Fermi, we sort of use/abuse this feature of HTCondor to get more control over our containers. Essentially, we push the users into containers without them realizing it. So there is no Fermilab user is going to come in and say, I want to run my job in this Docker container. They automatically get pushed into one. And then if they want specific environments, we encourage them to use Singularity images. So how do we do this? First, sort of an example of a small snapshot of some of the auxiliary knobs that we have. So the Python wrapper that Docker knob points to actually again uses Condor Python bindings to read from Condor config files. So we have a unified config file structure where one of the files is our auxiliary knobs, and then our wrapper goes and reads some of these knobs and then decides what it wants to do. I sort of highlighted one here, and I'll come to that in a bit. So Fermi HTC Docker capable used to define whether a machine is capable of running a Docker job or not. Another example, we can pass whatever capabilities that we want. Of course, since we are a DOE site, that means we have stricter security requirements. So we have trusted images that the wrapper can then read and make sure that the user is not trying to override anything. So this is what I mean by more control. So I kind of want to tie this into 2 more features that HTCondor has. Job transforms. So did you know through job transforms, you can do whatever you want to a user's job within reason, of course, at submit time. So you can add stuff, you can even remove stuff, unset stuff. So there's a lot of flexibility there. And then there is another feature that's called job machine attribute feature that lets you essentially pull whatever attribute you want from the *D ads into the job ad. So the way we push users into Docker containers is essentially by saying, well, we want this knob Fermi HTC Docker capable. And then maybe I missed a did you know here. Most of the Condor class ads on the job side don't have to be values. You can put expressions in there as well. So want Docker, which is generally true or false. You can see here we are saying if this Fermi HTC Docker capable 0, which is the first iteration of or the first run of the job that pulled in this value is defined, if it's undefined, use false. Otherwise, use whatever value that you have. And we do this because, I mean, like I talked about Fermi grid, for example, it breaks into the OS pool as well. So we need to make sure that our jobs can both run on pilots and on our worker nodes at the same time. I mean, if we set this to a static value, then you're going to have a conflict because pilots are not going to give you Docker. So yeah, like I mentioned, those were the three uses that I wanted to go into a bit more detail on. I'm going to touch the other ones as well. Worker node health checks. So like you already saw, there is a lot of power in HTCondor's class add language. So did you know you can actually add arbitrary class adds even for your daemons? So things like, if you want to monitor on the number of jobs that a SCED is running and you want to see if it's really close to the max running jobs that it has, and you want to make sure that, let's say, it stops talking to the negotiator at that time. So you can incorporate some of that using daemon health monitoring. Whole node scheduling, you can schedule nodes as a whole. We talked about P slots already. Todd mentioned them. Virtual slots, you can lie to Condor. You can tell it you have more CPUs. Job router hooks, if you don't like what Condor job router is doing, you can write your own hook and Condor will just invoke it when it's routing the job, and you can do a lot of things with that job as well. JDL magic. So I think that was Brian's brainchild, and it was discussed a few years back in Condor Week. So we kind of took it, applied to our use cases, and we use it pretty heavily at Fermilab. And the idea behind JDL magic was a Condor class add doesn't have to be a value. It can be an expression. And you can imagine how many things you can do with request CPUs or request memory in this case. FS remote authentication. So I have a gripe with Brian. He missed this authentication method yesterday in his talk. So you should have covered this one too. We use it at Fermi because it probably goes against the idea of access point, but we have user interactives separated from our schedulers in this particular case. And then we use a shared file system between them, which is again, don't throw stones at me, to authenticate using FS remote. HA defragmentation. So defragmentation daemon, in case you guys don't know, is one of the lesser talked member of the HTC SS. It essentially allows you to drain your worker nodes based on expression. So you have, let's say you have a mix of jobs with single core and multi-core, or if you are running in a multi-VO environment, it lets you make sure that there are always certain number of machines available. One of the unique things we did with the defrag daemon was we run it in HA. So the HA daemon, you generally associate with a negotiator where you're saying, make sure that the negotiator is up. If it goes down on one central manager, bring it up on the other. We actually run our defrag daemon in HA as well. I briefly talked about partitioning the tier 1 facility into 3 different parts. We do that with multiple negotiators, another flexibility that HTCondor offers us. And worker node health checks. So if you don't already know this, look up start decrons. Basically, Condor can run a script for you that you can then use to determine the health of your machine. And then you can use this to set yet another auxiliary knob that you can put into your start expression and decide, this machine doesn't have CVMFS, so you don't want it to match more jobs and run. And I apologize, I probably should have had more slides, but in fairness, all of these could be individual talks on their own. Anyway, to summarize, we rely heavily on HTCondor, and I also wanted to take this opportunity to thank the developers. You guys are rock stars, and you are a huge part of the success that we have had operating our services at Fermi. So I really wanted to give you guys a shout out here. I'm being a little shameless here. If anything I talked about seemed interesting to you, we are hiring, please feel free to talk to me afterwards. And that's all I had. Any questions or comments?